All right. Good afternoon, everyone. We're going to be talking about not SQL versus NoSQL, as some people have been talking about. However, I did procure 4 spoons, and I'm going to make them fight. No. So we're not comparing apples and oranges.
Why am I here then, if we can't fight?
Interesting. You can do that if you want. So we're not going to be comparing them as in one versus the other. Why is this one like the ultimate solution? We're going to try to figure out where they fit in the overall scheme of things. So I guess the first question that I want to ask is, many people for new projects are actually picking NoSQL, Mongo, CouchDB, and so on. And these people tend to say relational databases are obsolete and NoSQL databases are the new silver bullet, regardless of how relational databases have actually made PHP really successful. So I guess, what do you guys think of that? Like, is that true? Why is that not true? It's a bit of a loaded question, I know.
Yeah, it's a good question. So if people start with developing an application, you might be in a situation where you don't know where you're going. Mm-hmm. And then the question is what you actually mean with a NoSQL solution, since it's a broad term meaning everything.
Right.
If you look 10 years back or so, everybody was using either Berkeley DB or was using custom file formats, so was using some form of NoSQL storage. Then MySQL came, and all these web people moved over to MySQL and using that. And then they figured, well, having to define my schema beforehand is a bit troublesome, and I want to start quickly and easily, and looked into different solutions for that. And I guess that's where people start with it.
Right.
If it makes sense or not, I don't know.
Anyone else? Derick?
New technology is always more fun than old technology.
Right.
So that is, I think, clearly a reason why people would try other things first, because it's cool and shiny. But it doesn't necessarily mean that cool and shiny is better or a better solution for their situation, right? And NoSQL solutions, they will be easier to prototype with because they are schemaless. And I think that might be a good point as well, where they tried it. And then they realized that, well, our prototype works fine. But there's other cases where NoSQL solutions, are more often outfitted to scale a lot better. And for many websites, including my own, that is absolutely not necessary. I mean, my blog site runs on SQLite. But if you know up front in your startup that you want to have lots and lots of data, then it might make sense to look at solutions that are geared up towards scaling before you look at other solutions. And I think NoSQL tends to be better at scaling beyond a couple of machines, for example.
But so I think the scalability argument is valid, but I think it's a consequence of the wildly reduced set of features that some databases have. Like, a lot of the NoSQL databases really are just glorified caches. If you think of Redis or something, people think of it as a NoSQL database, but you could also argue that it's just a memcache on steroids, right? Because it's still single-threaded, you'd still have to do the sharding yourself, et cetera, et cetera, et cetera. So, yeah, and what you said about new technologies being shiny, that's basically happens to every technology, unfortunately, that, or fortunately, you could argue both ways, that something new comes out and there's a hype because, all the hipsters pick it up. And then, so like Node.js is a really good example, because everyone programs the most complex things in Node.js now, but it's just an unmaintainable mess because it throws all old conventions overboard, and it's all, oh, it's an event loop, so it's non-blocking I/O and it's web scale. It's nonsense, right? So, and often the wrong technologies emerge from this, because you have this spike in adoption, and then people figure out, okay, so what is this stuff really good at? And then they might abandon it for many use cases they used it for initially. So it gets this surge in adoption, and then it settles down to like a meaningful. I guess it's one of the reasons why MySQL became so popular, because people needed a SQL database. It was easy to set up back then, many years ago, and that's why it's in such wide use today. And then that happens to other NoSQL databases at the moment, like MongoDB, for instance.
Fantastic.
It's
So-
over. Yeah.
Let's let Dave talk a little bit as well.
Well,
Let
you
the Jim-
mentioned using the technology despite whether it was the best solution or not. The old joke is the bureaucrat who calls up the business and said, I want a list of your employees broken down by sex. And the human resources manager says, well, none broken down by sex, but we do have a couple with a drinking problem. The funny thing that I'm watching right now is being at an age where I see the technology pendulum swing back and forth. What's funny now is everyone's going, okay, we have to go to NoSQL databases, and then MySQL adds a NoSQL access, and then MongoDB adds indexes. Maybe this is going to be a moot argument a year from now.
Possibly.
Possibly.
I think kind of going on from there, I know a lot of people in here are really interested in knowing what are the good use cases for relational databases? What are the bad use cases that people keep on doing over and over again? And the same question would go for NoSQL at the same time. Like, where are the bad use cases for each one of them, and where are the good use cases? What's like a really good, solid example?
Well, the traditional relational model is you want to know how much is in your bank account, and you want a dollar and cents figure. So like with Hadoop, I want to know how much is in my bank account. Well, we'll run the map reduce, come back tomorrow, don't spend any money in between. There's always fringe cases where you're in between. The trouble with in this world is most of our data is relational. There's a lot of non-relational data that you need to find. But the traditional problem that drives SQ up the wall is you want to know your friends' friends' friends on Facebook. Trying to write that in a structured query language query is going to drive up the wall. It might be a little bit easier with some other non-relational database, but it's more like what data are you trying to get and how do you grab it? How do you massage it, and then how do you interpret it?
Right.
All right, so transactional databases like MySQL and older traditional databases, they are really good for the point to guaranteed exactly at that moment it's done. The problem is when you mention you have to join about 12 tables, because if you do relational databases properly, everything is third or fourth or fifth normal form, which is nice. It's like you don't duplicate data, but it doesn't necessarily mean it's the fastest way, right? Of course, there's reasons around that. You don't have to have a fully normalized database. And the NoSQL databases, they go to the point where it is better not to have a normalized schema. They are okay duplicating some data because it gives you some other flexibilities. Yeah, I'll think a bit more.
And well, there's one more thing. With a relational database, you can make joins. So you can combine the data you're having in different places and create some reports, some results out of this. With different NoSQL solutions, depending on what exactly you're looking at, you have a different degree what information you can actually request in what form in the end. So you have your schemaless data in there, but can you easily collect everybody of a given sex, like in your example, afterwards?
Just to drop in for now.
Yeah.
Having a schemaless database doesn't mean that you can just toss in information as much as you can. But instead of thinking how you structure your data, you structure how you want to access the information, which is the point you use to design your schema.
But I would argue that I think one of the reasons why we're seeing such a high adoption of NoSQL solutions these days is because the whole big data thing. There's so much information like on the web, like the whole more and more user-generated content, etc. So it's a lot easier to evolve a system that you build if you know that you don't have to do schema changes, with an alter table for 12 hours where you're just in read-only mode and stuff. When in comparison, like in a CouchDB or in a MongoDB, you just throw in the information, and then later on you change your schema slightly. I mean, you need to update everything to accommodate that, but still you can make it work like fluently, right? It's funny though that we talked about the bank account as the prime example for transactional databases, because bank accounts are not transactional, but that's the different story, I guess. But yeah, so the NoSQL solutions, I think what you said is about the joins is it's a lot easier to think in terms of joins in a relational database because your result table just gets more columns, right? Whereas in a NoSQL database, like MongoDB can somehow embed, I think, foreign objects, whereas in CouchDB you build a clever index where you have like the row, then the related row, then a normal row, then a related row, and stuff like this. So, and that like requires a whole different mindset when you develop something for it.
All right.
One more thing I want to add there. You said in a relation model, the schema changes are expensive and complicated. It's not directly needed in a relational model. If you look at a product like MySQL cluster to be there specific, there you have online alter tables. So you can add columns, change columns without having the long interruption where the complete table has to be rewritten. So even with a relational model, such solutions can exist. It's not directly bound to the model itself.
And it's expensive.
Yes.
You need to use mics.
Like this.
All right, let's move on from there a little bit, I guess. So there were some specific questions on Twitter that I was looking at, but I'm too lazy to look through there just now. Does Mongo support joins and stuff like that? It's apparently one question, but it's awfully specific. So I guess like to, all right, who cares? Yeah. So just to kind of take all of what you guys said there was that, at least in my experience, NoSQL databases, their strong kind of side is to deal with, for example, logs and information that just keeps on flowing in, and you don't care really what they look like, what the schema looks like.
But most NoSQL things are overload for just processing logs.
Yes, they're really good.
You need
for
a key value
big
store
data,
for that.
But whereas relational databases are really essential for financial institutions where things have to be up to date, like at the second. We have to deal with transactions in many ways. I think is what came out of this in many ways, unless you guys still disagree about that. No? All right. Fantastic. So what about, so here's, I guess, I'm going to be the straw man. You need to be more aggressive.
Okay. I can do that.
Yeah. So what would a hybrid system look like, I guess, if we decided to join these two systems into either a completely new database or making them live side by side? Because there is, for example, the NSA in the US, they released their own NoSQL database. That is an institution, a government institution. You would never expect to go for NoSQL for some reason, but they did, and they released it open source. So there is a definite need for big data out there. But I mean, what are relational databases doing to deal with that? And how can that be like?
No, so there are different things which are happening. So if you look at, I mentioned BerkeleyDB before. BerkeleyDB 1 year ago added an SQL interface. Now BerkeleyDB isn't what most of you would see when you're seeing NoSQL, but it somehow fits in that area. So they added an SQL interface on top of it. On the other hand, there are products like MySQL Cluster, which is, in a sense, a NoSQL storage in a cluster database, and you can put SQL servers in front of it, translating the SQL into these more NoSQL-like calls in the backend, which then can be used for lots and lots and lots of amount of data. So on both sides of this area, there are movements in one direction, from one direction to the other, and the other way around. And I guess that will continue.
Are you suggesting to use MySQL as an ORM? Translating from queries to other queries? Because that's what it really does then, right? Why do you want to have that in front of your MySQL cluster, which I don't quite understand what it does?
So the question is what kind of data you have and how you want to access your data. MySQL, I stay with the example. MySQL cluster is a distributed system. You have different servers which store data in some form of tables where you can access them by primary key and get the values out and can do index lookups. And then there's the MySQL server, which translates the SQL statement to access to this data storage. The benefit there is that you can do all the SQL kind of stuff. You can do join operations. You can do all that if you want. And if you don't want to go that way, you can use MySQL cluster in a way which is used by telcos, which directly go to the low-end storage and using it in a different way, which can be fast in some ways.
But what does this low-end storage support? Like, is it just a big table implementation thing, or how? Because it seems like there's NoSQL, the SQL doesn't map very well to that. Why would you put this abstraction in front of it? Because there's lots of really weird magic stuff going on that's going to bite you one day because it just stops working or it doesn't scale.
It's an ORM.
Is it? How much does it cost? Is it commercial? Is it open source? The MySQL cluster? Is it completely free?
Yes, it's of course open source. The cost there, well, it's not unstructured data. It's still structured data.
So you have table definitions.
Yes, yeah.
Dave,
I don't
yeah,
know in
say-
detail, but Dave will.
What's really funny to me is we're talking big data, and in the open source world, our idea of big data is actually fairly tiny. My friend from InfoBright, what's the average working set of one of your installations?
Average working sets, we're absolutely into the terabytes, and you were talking about telcos. We've got a JDSU. They're petabytes, and their average knock is anywhere from 5 to 45 terabytes of working data, and that's what they intend to be, accessing, randomly at high speed, doing analytics.
Yeah.
So, I mean, and that's, we would absolutely place ourselves as a SQL database until somebody goes under the covers, which is sort of the point.
Yeah. What's really funny is InfoBright is not a big player in that market. If you go out to the Teradatas, they're running gazillions of boxes with much more data than you can even have a nightmare about. So us talking big data is kind of like a 7-year-old discovering a new curse word. Big Brother's rather amused that you're talking about that word when you haven't discovered this word yet, which is much more powerful.
Interesting. All right, so does anyone have any questions out here? Just so to give the floor. No? Is this too heavy? Do we need to
Difficult
lighten it
questions
up?
are okay too.
I can dance.
Yes,
All right.
please go dance, Helgi. I'd like to see that.
Oh, really? You need to get me a little bit more drunk. So a few people have been asking, is NoSQL ever going to standardize on their kind of interface to the databases? That is,
No.
well, all right. I'm
I will say no,
I'm gonna counter that by saying
because
yes.
there
because-
are the NoSQL databases. They're a lot more different
Yeah.
between each other than different variants of relational databases.
Right.
They
But-
have a different query language, a different layout, different ways how to do scaling.
At that
Everything is different.
Purpose.
Different purpose.
At
Everything.
that point, though, the reason why relational databases got really popular is because of the SQL language itself. That was what actually kind of brought things into, the common DBA's world, I guess. And so looking at what CouchDB and SQLite are doing with, it's called UNQL, or UNQL, makes it interesting because they're trying to kind of provide a unified interface to two databases that are not even related to one another.
I guess you could make that work in at least certain cases. But if you look, for instance, at the query language that MongoDB has, and it would be impossible for anything even remotely similar to that to work on top of CouchDB, because CouchDB is just so fundamentally different. In CouchDB, you write views to produce indexes, and then basically you do just key lookups on the index or scans, and you just fetch a range of documents or results that you pre-computed. That's also, I think, the thing that the actual big data stuff like Hadoop, etc. I wouldn't consider that per se a NoSQL solution either, because Hadoop has nothing to do with random data accesses. So it's just a technology you use to compute. Like you break terabytes of data down into something accessible, and then you maybe put it into an HBase table or something for quick lookup, right? And at that point, it becomes a NoSQL database. But it's not like you're randomly querying the just unstructured data that you pump into it. You need certain computational steps to produce something that makes sense to your application, and then you can get meaningful data out of it, but not just.
What about something like a PDO interface towards?
Oh my God.
All right.
I hope not,
I think
because
that
PDO is
answers
such a
that.
train wreck, and if they tried that for
But
SQL.
conceptually though.
Well, you could you'd have like maybe make a connection, fetch an item by ID, and fetch what else? It's, yeah, for CouchDB you would say fetch me an index. For MongoDB you could say fetch me something based on this query. And that's already where the differences start, basically.
Does anyone out here want to comment on that?
There is one.
Oh, hang on, Mike.
There is a PDO interface for Cassandra now, for SQL. So it does exist in the NoSQL world. For Cassandra?
I think the mic was not working. So apparently there is a SQL interface to Cassandra. So Cassandra.
No,
PDO, sorry. It's all the same.
How do you make a query?
The PDO is a bit of a weird thing anyway. It has nothing to do with SQL. It is just data access layers.
It's
right?
just an abstraction
There's
layer.
nothing to do with SQL at all.
Right. So the whole
It's
concept
just-
is: are we ever going to have abstraction layer on top of our NoSQL in PHP perhaps, or client libraries?
In PHP, perhaps, yes.
Yes, that was.
But yeah, yes, you have a good point there.
Guys, you really need to learn.
So,
to do
so PDO is, I mean, that works because all the databases that you access with it have the fundamental concept that you have tables with rows and columns, and you make a query, and that still is a table basically that you get back with rows and columns, right? And with different SQL databases, I mean, a big table is completely like any big table implementation, like HBase, completely different from, say, MongoDB. What MongoDB would return you, for instance, in case of a join, versus what CouchDB would return you in case of a join. It's just I don't think you can fit it into one concept without making huge trade-offs where you lose functionality that make these individual solutions unique. Because it's not just PHP doesn't have that, like Ruby doesn't have such a system, Python doesn't have such a system. There's the doctrine ODM, like the object data mapper thing. Even that doesn't have even like a common way of setting up a connection to MongoDB or CouchDB. It's just
Interesting.
because I don't think anyone sees a point because they're way too different.
So I guess the result of that is that it's not happening unless someone is really brave.
People will try to do it, and they might have some success with it, but I don't think it's very useful.
And then they'll want an XML and JSON.
Yeah.
Exactly.
No.
So.
But one last thing, maybe, like if you run your stuff on MySQL, it's an effort, but you can migrate your stuff to PostgreSQL. But I think if you run on CouchDB, it's so fundamentally different from MongoDB, where you would have a really hard time with it. Like you could rewrite stuff from scratch, and then a common way of opening a connection to your database so is going to be the least of your problems.
So it's kind of a question that we kind of had before, but is there any point in combining SQL with NoSQL? With the later acting as a materialized view? Overkill? Crazy?
I don't see the point. I mean, it makes sense to have both a SQL database and a NoSQL database, but I can't see why you want to have an extra layer on top of that to make things slower again.
All right, fantastic. So one question that I got asked. You want to? All right, fantastic.
Right, you're talking about combining NoSQL and SQL and having a hybrid system. Currently, we use MySQL and we try to save data in JSON format in a string column, and then we retrieve that, and then we do the decoding and then use a variable. Is it possible to have a data type in MySQL that supports that natively, so that we don't have to do the JNC encode and decode?
The question there would be on different levels where you could go into that problem, which is then again very specific to the MySQL and to the relational model. One could build one abstraction layer pure in PHP, which does that already, translating that into SQL statements or something like that. For accessing MySQL, what MySQL 5.6 will bring is an Memcache interface where you can send data using the Memcache protocol to MySQL. And so Memcache protocol is key value based, basically. So you have a key and send some value, and the MySQL server then can split up the value in there to fit it in different columns, which goes a bit in the direction which I got from your question. Other than that, I don't know, but David is going to.
I don't think that'll help him much, because I think fundamentally your question, I think your problem is not relational, really. So you have a complex data type of your own basically in a string column, like it could be a serialized PHP object or JSON or whatever, and that's a really strong indicator that in that particular case you might be better off with a NoSQL solution, because you could have it like as an inline object, and then query that, because that's basically where the NoSQL solutions shine, because you don't have to, mend everything into a relational schema. Or abstract all your tables in such a way that everything is basically just a massive key value thing that you join, where you join 15 tables, because that kind of defeats the purpose of a relational database.
So if you do something like that with a relational database in general, and you have such an object, the best thing you usually could do is create a blob, put it in, and then forget about it again. Then some relational databases have XML functions to query data in there if you're storing XML data. And such things are there. Maybe some database will do something with JSON, that you have JSON access functions. So as long as you're in this relational model, if you're dropping in random data, it's hard to combine with relational model.
All right. I think that wraps that kind of up. There's one question which I actually find quite intriguing, is in some NoSQL databases, specifically CouchDB, your data is actually versioned. Everything you put in there is versioned, and you can actually start comparing. Well, up to a point. You can actually ask for a diff of your commit. If SQL was going to try to do that with the data, is it possible? Is it a massive overhead? It's kind of a question for Dave over here. Is it possible in SQL, basically, to do versioned data?
One thing, before I hand it off.
Well,
So
is it exposed well enough?
CouchDB,
that's the question that someone on Twitter had.
CouchDB only keeps revisions around for master-to-master conflict resolution. So you can't use the revision functionality of CouchDB to reliably store versioning history of your stuff, because the older versions are never replicated, and they could go away at any moment. So unfortunately, which it would be cool otherwise, but it's like if you look at the underlying implementation and the concepts for the replication stuff, it becomes clear why it's not possible. But the rest is for you guys.
I'm sure you could do some sort of revisioning, but the classical SQL model was, why don't you make that the revision a separate record with a different revision number on it?
And that would probably be really expensive.
Yeah, so you like you said, it's a different can of worms. Which side of the nightcrawler do you want to grab?
Yeah, all right. So I guess that basically says it's almost impossible unless you have the ability to store loads and loads and loads of data, is the basic answer.
Well, you got to remember, loads and loads and loads of data has changed over the years.
Yeah.
How many of you used the old 3 1/4-inch plastic floppy drives when you were growing up? Woo. Okay. How many of you used the 5 1/2-inch? Okay. Now watch the people with the gray hair laugh. 8-inch floppies. No. Oh, those were much better than punch paper tape and cards, believe me. So, yeah. So the numbers we're talking about, big data and all that, what we're talking about now being limits are going to be laughable in a year or two.
Yeah. All right, fair enough. That kind of answers that question. Do you guys have any questions in the room? Do you have questions for one another? No. All right. So.
Yeah. Well, what's real funny is a lot of you folks may not realize it, but the database and NoSQL world are actually fairly small worlds. We run into each other at conferences. We know each other's developers and run into each other. And there are some folks who thought this would be a match grudge fight, which it really isn't. We tend to respect each other and do fairly well with each other because we're all facing the same problems. The trick is, how do we get the data to you folks so you can use it?
Wow. We have special people here up on stage, just FYI. So there was a person that asked me before the panel, with SQL, you have DBAs. That's like a dedicated role. It's a really complex thing to configure a proper relational database and make the schema in general work. Whereas the kind of schema development with NoSQL databases seems to have moved more to the programmer, and there's less need for as many DBAs. What's your take on that, I guess, from both perspectives? Is that true, not true?
Well, if you're having lots of load on your system, you always need people who know the system well enough. independently, whether it's a NoSQL system or whether it's a relational system. You have to know what kind of access works, what kind of queries can you send it, how do you configure it, what kind of hardware should you use for it, all that kind of information. If you then look traditionally at MySQL years ago, or sometimes even nowadays, the developer and the administrator for the system and the DBA are all the same person in many PHP use cases. And if the operation becomes larger and larger and larger, you add more and more people who are specializing in different areas of your overall system. So you have developers who know one area of the code, you have developers knowing other areas of the code, you have admins who know about the system, you have admins who know about the database, and then you see again, okay, it becomes too complex, so we are adding DevOps who are something of all of that again. And so that's a constant change depending on your organization, how many people you want to use on it. Do you have enough money to pay 20 people, or do you want to have less people who do more things at the same time? And I don't think there's a general answer to that.
Well, I think there is a general answer that the NoSQL databases have been around too short of a time to really generate the equivalent of a DBA. It used to be if you were a programmer, you did the operating system, you did the application, and they were both the same thing. And things differentiate over time.
Fair enough.
I'm just holding the mic.
Oh, you're just holding it? All right.
That's okay.
So I had a specific question here. I'm trying to find it.
Well, there was a request for you to dance. I saw that disappear.
Yes, yes. We might do that at the social. Are there really no questions? Is this too... okay. There are actually a bunch
plenty
of
of them.
questions
I see
here. I know there are a
hands.
bunch up there, but we've asked some of them.
But
I want to get people in here to ask some questions. Be a
Can't
bit
see anything else
involved.
but him, but yeah, you go first.
The audience might dance.
No?
Yes, but not with Mike.
So if I had a social application that scaled really massively globally and I built that in SQL, right, do I reach an inflection point where I should be considering NoSQL?
Depends a little bit how much you want to replicate between them, right? If it is important for people in the US to have access to data in Europe, then you need to come up with a solution that allows you to replicate them, but make sure that not all of the queries also go to the US if you're based in Europe, right? I mean, looking up your friends' profiles, having to do that with queries that goes to the US is a bit of a pain because it's slow.
If you operate at that global scale, where you need to, like Facebook, for instance, they for a very long time had the issue that they would replicate between the east and west coast of the United States, and if you were somewhere in the middle of the United States, you would post a status update, and then refresh the page, and it's gone, because it's the first time you hit for the write, you hit like the west coast service, and then for the reading, you hit the east coast service, and there was a bit of a replication lag, but you can't just you can't just take any NoSQL solution and expect things to just magically work better, right? Even with Cassandra or something that works for the amount of data, but you still have a lot of issues to solve. If you use MongoDB for it, it's just not going to work at all. I'm just trolling. You can answer that later, because no, yeah.
Give the mic to Derick.
So David likes giving MongoDB shit, but that's okay. He just doesn't know what he's talking about. But in newer versions of MongoDB, there's some functionality available that allows you to have at least your writes go to specific data centers. That has like data center where sharding and things like that, and replication. That's also going to be implemented for reads. So even though that will make it better, I mean, in order to have fast access to your data, you need to have it all very local, right? But there's ways on how you'll see more functionality getting implemented to optimize the reads and writes to something that is very local. I think.
So I guess on that point, I actually have myself a question in regards to MySQL. And it's around the handler sockets and how the handler sockets are making MySQL potentially much faster. Do you guys not?
Is that too low? That's too low level. Next question. Sorry.
Do I need to talk about that? I don't know.
I don't know. I wanted to still with the scaling globally thing, right? Even if you have replication set up between data centers, then you need to think about, well, do you shard, for instance, do you shard writes in such a way that, or do you make sure that every write goes to your regional data center first and then is replicated? So do you keep a replica of the whole database, which means like all of Facebook's stuff is in Asia and in the United States and in Europe, and it's kind of as much in sync as possible? Or do you shard by region? Because that's difficult. You need a lot of server capacity in that case, right? If you then say, okay, I just shard content by region, so if I as a European want to access something in the United States, but basically transparently for the application, this is something MongoDB does. For instance, you can query multiple shards, right? But not every query operation that you do then can be done in parallel across all backends. So if you have 10 shards, some of the operations that you do in MongoDB, right? For instance, because that's a symptom of this. I'm growing my stuff. It's not a fault. I'm not saying MongoDB is stupid for that. It's just a logical problem. Like nobody can solve that because it's even physics. It's just speed of light and everything.
All right.
Like there are logical problems if you want to query something and
we had a question
in parallel versus sequentially.
We're almost done. So
Hello,
we'll
world.
take another question there.
What's the future of the MySQL project, and how actively developed are all of these different databases?
I guess it's too specific for a NoSQL versus SQL panel, but it's going to be continued with development. 5.6 will come out sometime. There are many changes in 5.6, and there are plans for later versions. So there is going to be lots of development.
Exactly. I agree.
I can make a MySQL 5.6 and future session out of this, but I guess that's not the purpose of this event here.
Do we have time for another question? All right. Any other questions?
What time is it?
It's almost time. So yeah, we had a question actually on Twitter. So for example, with CouchDB, it's really easy to sync your data from a mobile device over to a server and back and forth. But what about SQL? Is there anything in that world?
Your phone company does that now.
With what technologies? Like, I guess is the question.
Yeah. As you walk around from cell to cell,
right,
you're being tracked by a MySQL cluster.
If you check in on Foursquare, you're tracked by MongoDB.
Yeah. So.
All right. So cell towers track us with MySQL.
Just trying to say that there's different solutions that have lots of data on you, basically.
But specifically on the mobile device versus on the external devices that we're paying.
You're transferring packets, and all we can hope is that the iPad 4 solves all our problems.
Well, I know Dave. Dave has the right answer. I know.
None of the databases you can run on your mobile.
Yes, you can.
Yes, you can. MongoDB, you can.
Derek. Damn it.
An issue. So there are systems which you can run on your mobile phone. There is a CouchDB which can run on your mobile phone.
No.
And the question is,
hand over the mic.
Buy me the mic. So there's a difference between you can and MySQL is doing that, and it's just packets, it's just low level, it's just network traffic. Between that, it's doable with any solution. Like I have a tasks, a to-do list application called the Hit List on the iPhone that syncs with the cloud and the desktop application, but it's SQLite. And that's a pain in the ass to do. And like solutions like, for instance, CouchDB. CouchDB is built specifically for that use case. You have master-to-master replication. You have conflicts. And it's not trying, for instance, in Cassandra, I think if you have a split brain for a moment, because you have multiple master servers that get writes because in the event of a network petition, and then the petition is removed, so all the servers see one another again, then I believe the newest record wins is basically taken as a default. Is that correct?
All right, that sounds good to me.
But so in CouchDB specifically embraces that situation. It says there will be conflicts, and you as a programmer, you will be notified of that conflict, and you must deal with the situation. And I think that's probably the easiest way to build such a thing, like a syncing solution. If you do it and try to do it on top of a SQL database, you have to do it all yourself, because it's not a fundamental concept in these database systems.
David, shut up.
Right.
I'm going to take a last question because Karen is about to kill me here. So I'm going to...
Can you give me an example where an SQL would be used for a particular solution where MongoDB wouldn't be very good for, and vice versa? Because I hear a lot of people where it's useful for both, but it doesn't really help me because I wouldn't know where one would definitely be a better solution than the other. Is that a good question?
Yeah. We kind of touched that
So
at the start. But
if you have highly transactional data, you need to do many, many updates that absolutely have to be done in that order and isolated. Then you would pick a database system that supports those kind of transactions.
which is not usually NoSQL.
Such as?
Oh, PostgreSQL, MySQL, doesn't really matter which database you use there, right?
Right. All right. I think we're
Okay.
done. Thanks a lot, everyone.
Well, and just to answer an example
or
for
not.
MongoDB or something like that,
Okay.
if you don't know your schema, it might be better there. It's a simple example.
The example we had earlier with the
Use the
string
mic.
column, the string column that holds JSON, or the string column that holds XML, or the string column that holds serialized PHP stuff, then you know you're doing something wrong. And if it's no, because wrong as in you either use the wrong solution or you don't have your stuff normalized enough yet. And usually you don't want to, because you end up with 1,555 tables, and it's just going to be so painful to even just write the queries, because it's not an object.
All right. All right, fantastic. Thanks everyone for coming and bearing with us. Thanks to the panel. You guys should stand up and bow.
At least
It's
he didn't write
fantastic.
rollback transaction because that would be pointless.